Today's industrial marketplace is home to a countless number of power transmission products. Power is harnessed with such efficiency that production moves forward at an incredible pace. A pace maintained by the efficiency of power transmission components. This program will focus on a small but crucial component of the power transmission process, the V-belt. The program will explain why V-belts are so effective, detail their advantages, and show how to identify and select the correct style of belt. V-belts are simply transmitters that effectively link a power drive to a needed function. The belts are easy to select, simple to install, and offer years of reliable performance. The first V-belts appeared in the early 1900s. They were cut from leather and fabric, and they replaced existing drives which used rope running in V-grooves. Modern V-belts are constructed differently. They are made of natural and synthetic fibers and rubber, but they still utilize the original wedge concept to harness power. The wedge-shaped belt fits into the wedged groove of the sheave to create a matched fit. When the drive is activated, the pulling power comes from the action of applied tension, which forces the belt to wedge tightly into the sheave groove. By using the wedge principle, the V-belt gains the advantage of tremendous gripping power. Besides this power advantage, the V-belt offers many other advantages for industry in its efforts to reduce equipment repairs and minimize downtime. When an operation demands efficiency and minimal maintenance, the V-belt drive is the logical choice. Unlike roller chain, V-belts require no lubrication. They offer smooth starting and running. They cover wide horsepower ranges. They permit a wide range of driven speeds. They are quiet and efficient. They dampen vibration between driving and driven machines. And they act as a protective device because they refuse to transmit a severe overload of power, which could damage equipment. Finally, V-belts wear gradually, making corrective maintenance simple and easy. V-belts are so effective that even when proper installation and maintenance procedures are neglected, the belts will operate with some degree of success. A V-belt is designed around two concepts, strength and flexibility. The strength is provided by a row of tensile cords. The cords serve as the load-carrying component and are made of twisted synthetic fiber. The compression section is made of synthetic rubber. It supports the tensile cords evenly and compresses while bending around the sheaves. Conversely, the tension section, located above the cords, is designed to stretch as the belt bends around the sheaves. The cover or top fabric is made of a rubberized fabric designed to provide wear resistance and increase belt flexibility. In more recent years, belts with a cog construction have become popular for specific applications. The cogs offer greater flexibility, and with proper usage, it is possible to get up to 25 to 50% more belt life than a standard V-belt. The cogs make it possible to use smaller diameter pulleys, resulting in more compact drives. Additionally, standard V-belts generally have an ambient temperature limit of 140 degrees Fahrenheit. A cog belt can operate slightly above this limit because of its ability to minimize heat buildup. While the V-belt's basic design may be simple, the applications demanding its services are complex. That's why the standard V-belt has evolved and expanded to fit the needs of industry. The increasing demand for higher productivity has resulted in a wide variety of V-belt designs capable of handling specific applications. Each V-belt type is a specific design for a specific function, and the identification nomenclature is different for each belt. The differing ID numbers make identification and selection simple. This allows for quick replacement and minimal downtime. If the ID numbers have been worn away, the belt size can be checked by using a V-template gauge. The most common belt type is the classical or conventional V-belt. The classical is also known as a multiple belt because one or more belts of the same cross-section can be used on one multiple drive. Typical applications for the classical V-belt include industrial fans, blowers, conveyor drives, oil field equipment, and agricultural equipment. Classical belts are also available in the cog construction. The dimensions of the classical belt are identified by the prefixes A, B, C, D, and E. Each prefix indicates a standard top width of the belt in inches. For example, A indicates 1/2 inch top width, and B indicates 5/8 inch top width. The classical belt is also available as a cog belt, offering a higher capacity. The cog belt prefixes are AX, BX, and CX. The second size dimension is length. The true length of a classical belt is defined by a datum length. The digits indicating the nominal size represent an approximate inside length. For example, an A42 belt indicates a top width of 1/2 inch and datum length of 43.3 inches. The approximate inside length is 42 inches. Another common belt type is the fractional horsepower or single V-belt. FHP belts are light-duty belts used when the prime mover is a fractional horsepower motor or small engine. Typical applications include appliances and many small machines in industry and around the home. The top width dimensions of the FHP belt are identified by the prefixes 2L, 3L, 4L, and 5L. But while the digits in the classical designation indicate inside length, the digits in the FHP belt indicate approximate outside length. For example, a 3L 380 belt means a 3/8 inch top width, the L indicates light duty, and 380 means 38 inches outside length. Another popular belt type is the narrow or V-series belt. Although narrower, their tensile and load-carrying sections are as strong as those in the classical belt. The narrow belt is designed this way to allow for more work in less space. The applications are the same as classical belt applications, and the belts are used with multiple drives also. The narrow belt works best with compact drives, drives of lesser weight, and drives needing greater horsepower capacity. Cog construction is very popular for narrow belt applications, and narrow belts also use the X to denote cog construction. Top width designations for narrow belts are 3V, 5V, 8V, 3VX, and 5VX. Narrow belts are measured by effective length in a standard measure pulley, or the approximate outside length of the belt. Therefore, a 3VX 450 belt would indicate 3/8 inch top width and 45 inches approximate outside length. The X indicates a cog belt. The need to resist drive instabilities brought about the joined belt. Joined or banded belts consist of 2 or more belts whose top fabric is joined to create one unit. This design is effective for pulsating drives that would cause single belts to turn over in the pulleys. Joined belt ID numbers use the same top width designations as the classical and narrow belts. To get the part number, simply add the number of belts as a prefix to the standard belt number. For example, a 3-belt wide BX75 belt would be labeled a 3BX75, the 3 designating 3 belts, and BX75 for the belt size. The great variety of drives and innovative machines has brought about the need for a number of belts for special applications. A good example of a specialty belt is the double V or hexagonal V belt. While the driven shafts on most machines rotate in the same direction, some applications call for the shaft to rotate in a direction opposite to that of the driving shaft. The double V belt was designed for these drives because the belt will drive from either its top half or its bottom half. The construction of a double V belt is similar to the classical design. Therefore, the ID numbers are easily identified as AA, BB, and CC. An AA42, for example, is the same as the A42 or AX42 on a standard measure pulley. Other specialty belts have appeared in recent years, and with the advent of different drives, these belts are in great demand. One specialty belt with a very specific function is the variable speed belt. Variable speed belts are designed to provide speed variation in a drive by working with adjustable sheaves. Other specialty belts include open-end V belts, V-ribbed belts, and dry can belts. Even though the ID numbering system for V-belts is standardized,